Howdy, everyone. Welcome back. Today we are doing some more matrix stuff. We're going to look at determinants and also inverse matrices today. So this may seem a little bit complicated, but once you get the hang of it, it's really not bad. Okay, so first of all, we need to talk about what is a determinant. Okay, and basically a determinant is just a numerical value that we can give to a square matrix of numbers. And when I say square, I mean like 2 by 2 or 3 by 3 or 4 by 4, any of those, for example. So a numeric value given to a square matrix. Alright, so what is a determinant? A numeric value given to a square matrix. That's what that says if you can't read it. So the notation for a determinant, we use these, instead of a bracket, we just use straight lines. So it kind of looks like an absolute value, but that means determinant. And the formula for a 2 by 2, and now this only works with a 2 by 2, but what you're going to do is you're going to multiply the diagonals. So you're going to do A1 times B2. So A1, B2, and then you're going to subtract the other diagonals. So subtract A2, B1. So A1 times B2 minus A2 times B1. Okay, so let's do an example. So I'm going to do a 2 by 2 matrix here. 5, negative 2, 3, 1. And the determinant of that, so I'm going to multiply this way. So 5 times 1 minus 3 times negative 2. So that just turns into 5 plus 6, which equals 11. So that's your determinant. Okay, another example. Let's do 3, negative 5, and 7, 9. Okay, so 9 times 3 is 27. Minus 5 times 7 is negative 35, so plus 35. And that gives us 62. So the determinant would be 62. Okay, you might be wondering what determinants are useful for, and we are actually going to get to that later on in this video. They actually will help us solve some systems of equations. Okay, so 2 by 2 is pretty simple. You just have to follow that formula, subtracting the diagonals. 3 by 3 is a little bit more complicated. So, step 1, first things first, finding the determinant of a 3 by 3 matrix involves a lot of steps. First, you need to know what a minor is. You can find the minor by crossing out the row and the column containing the element. Circle element A1 and cross out the row and the column in which it's located. So, basically when you're finding a determinant of a 3 by 3, what you need to do is you need to pick a row or a column to work with. Okay, and typically we pick the row or the column with the most zeros in it, or maybe with the simplest numbers in it, because that will actually make things a lot simpler for us. So if they do A1, then we are looking at that element, so we cross out the row that it's in and we cross out the column that it's in. Okay, so this right here, what's left, that's called the minor. Okay, so then it says write out the 2 by 2 matrix that represents the minor of A1. So it would just be B2, B3, C2, C3. So that would be the minor of A1. If we wanted the minor of B2, say, we're looking at this one now, we would cross out the row, cross out the column. So it would be the 4 elements that are left. So it would be A1, C1, A3, C3. And that would be the minor of B2, because that's the one that we circled. Okay, so all these elements can have a minor. Next, we will find the product of each element in the top row of the matrix and its corresponding minor. This step takes a while. So they're using the top row. Okay, you can actually use any row or any column. Like I said, it's better to use the simplest one, so the one with the most zeros or the simplest numbers. Okay, so, but they're just doing the top row because we don't really have any numbers here. So first we are finding the minor of A1. So we cross out these guys. So we get A1, minor B2, C2, B3, C3. Then we look at B1, cross those out. So we get A2, C2, A3, C3. And then C1, so we cross out these guys. We get A2, B2, A3, B3. Okay, so then what we do is we find the determinant of each of these 2 by 2 matrices, so the 2 by 2 minors now. So to find the determinant of each of those, we just multiply the diagonals and then subtract. So what they've done is we saw this A1 here, but then they do B2, C3 minus B3, C2. And then we do B1 times parentheses A2, C3 minus A3, C2. And C1 times A3, B3 minus A3, B2. Okay. And then we need to add or subtract all of these together. And how you figure that out, whether you're adding or subtracting, is I like to think of it as kind of a checkerboard. So if you have your matrix, so I'm going back to this one up here, the original one. It's a 3 by 3, and I'm going to make a checkerboard out of plus and minuses. So it's going to be plus, minus, plus, minus, plus, minus, plus, minus, plus. So all of the minors that have the plus sign, those are going to be positive. So we use the top row. So I have a positive, that would be this one, a negative, which would be this one, and then another positive, which would be this one. So I'm going to keep this positive, subtract that one, then add that one. Okay, so that's how I like to think of it. If we used, say, the second column to find the minors of, it would be minus, plus, minus. So it would be negative here, positive here, and negative here, if we had used that column. Okay, so I like to think of it as a checkerboard like that. Okay, this says once you've finished finding the products of the elements and determinants of their minors, we can finish by completing one subtraction and one addition. Okay, that's not very specific, that's why I wanted to show you the checkerboard thing. Okay, but once you add and subtract those, that gives you your determinant of the 3 by 3 matrix. So it's not too bad if you just keep everything straight. Okay, so let's see. So this is basically just restating what we did on the left side. So let's do an example. So we want to do the determinant of 3 by 3, so 8, 9, 3. I'm not going to put any zeros in this one because I want to actually go through the whole process. 3, 5, 7, negative 1, 2, 4. Okay. We could do the top row. That would be fine. However, just to change it up, I want to do the bottom row because, well, those numbers look the simplest, to be honest. So let's do the bottom row. So if you remember our checkerboard, plus, minus, plus, minus, plus, minus, plus, minus, plus. So we're looking at the bottom row, which is plus, minus, plus. Okay, so first, I'm going to circle my A3, which would be this one right here, and I'm going to cross those out. So I have negative 1, that's the one that I circled. That goes here. And then in parentheses, we do these two, subtract those two. So I'm going to do, looking at these guys now, because I cross out these and cross out these. Okay, so it's going to be 9 times 7 minus 5 times 3. Okay, I don't want to write these because I'm going to have to erase things. So 9 times 7 minus 5 times 3. Okay, and then next we go to the 2. We cross out these. So that's going to be 2, and actually it's a negative because of the minus right here. Okay, so it's going to be minus 2, and then in parentheses that would be 8 times 7 minus 3 times 3. Eight times 7 minus 3 times 3. Okay, and then last one, the 4. So this is going to be a positive. So plus 4 times, we cross these out, so that's going to be 8 times 5 minus 3 times 9. Okay, and then simplifying this should give us our determinant. So we get Okay, well, that all just froze, so I'm not really sure what I had there, but it should come out to be, if you go ahead and simplify yours, hopefully you wrote it down, should be negative 90 if you add everything together. Okay, so double check, make sure that's correct. If not, then maybe I did it wrong, but let me know if I did. Okay, so that's an example of finding a 3 by 3 determinant. All right, let's go to the next thing. Okay, so there's actually a simpler way to do a 3 by 3 using diagonals. So this takes 4 steps, but these steps are quite a bit simpler in my opinion. So the first step is to rewrite the first 2 columns of your matrix to the right of the determinant. Okay, so what we have here is we've got our determinant, so we're going to rewrite the first 2 columns next to it. So we have A, D, G, B, E, H. Okay, so now we have a 5-column matrix, basically, if you think of them all together. Then next step is we're going to draw 3 diagonals downward to the right, starting from the first row, first column. And we'll have 3 diagonals. Multiply the 3 elements from each set of diagonals and write the product at the end of the diagonal. So what that means is we are going to take and we're going to multiply these 3 together, these 3 together, and these 3 together. So we get A times E times I, we get B times F times G, and we get C times D times H. Okay, next step, you draw 3 diagonals upward. Okay, so same idea, except now we start from the bottom left. Okay, so we multiply this way now. So we get GEC, HFA, and then IDB. Okay, and now that you have those, we think of these ones as the positive products and these ones as our negative products. So we're going to add all the top ones together. So AEI plus BFG plus CDH. And then we subtract all of these ones down here. So minus GEC minus HFA minus IDB. Okay, and that will give you your determinant. So it's quite a bit simpler than the other method that we did before. However, the other method, this method only works with 3 by 3s. So if you want to do a 4 by 4 or a 5 by 5, you would have to use the method we did in the previous page. Okay, so let's do an example here. So again, these are just the steps on this side, so don't worry about writing anything there. So let's do this. So 3, negative 2, negative 1, 2, negative 1, 0, 1, 2, negative 3. So the first step is to copy down the first 2 columns again. So 3, 2, 1, negative 2, negative 1, 2. Okay, next step, draw 3 diagonals down. So this way, this way, this way. So if we do that, we're looking at 3 times 3 times negative 1 times negative 3, and then again 2 times 0 times 1, and then the last one, negative 1 times 2 times 2. So that gives us, what's positive 9 here, 0 here, negative 4 there. Okay, and then we go upwards now. So now we're going this way, and these are going to be the ones we subtract out. Okay, so this way we do 1 times negative 1 times negative 1. That's going to be 1. We do 2 times 0 times 3, which is 0. And then we do negative 3 times 2 times negative 2, which is going to make positive 6 times 2 is positive 12. Okay, so now we get those. And then the last step is going to be to add the top, the first ones up here, and subtract these ones. So you can go ahead and put it in the box. I'm not going to scroll down because I'll lose everything else up here. So I'm going to do 9 plus 0 plus negative 4 minus 1 minus 0 minus 12. Okay, and then we just simplify that. So 9 minus 4 is 5, 5 minus 1 is 4, 4 minus 12 is negative 8. So our determinant of that 3 by 3 matrix should be negative 8. Okay, this video might be kind of long because there's a lot of steps to these, but I'm going to try to hurry through these. Okay, so we have Cramer's rule for two variables. This says you can use your ability to find determinants of 2 by 2 matrices to solve systems of equations in two variables. So for example, well, step 1, it says write your linear equations in standard form. So that's when the x and the y are on the same side, so that you can identify the pieces that we'll be using while applying Cramer's rule. Your equations will need to be written in the form ax plus by equals c. You will be labeling your first equation to find value for a, b, and e. You will be labeling your second equation to find value for c, d, and f. Okay, so for example, if I have 5x plus 4y equals 28, and I have 3x minus 2y equals 8. Okay, this is the system of equations. I know that we can solve this by substitution or elimination, but we can also solve this using matrices. So for this one, our small a value is going to be this, b is going to be this, that's an a, and then e is going to be this, is 28, c is going to be 3, d will be negative 2, and f will be 8. Okay, so the first thing we need to do is find the determinant for matrix 1. So basically, you need to think of this, we're finding what x is and what y is. So the first thing we can do is we're writing a bunch of these 2 by 2 matrices. But first, if you want to find your x term, what you're going to do is you're going to write a matrix, but you're going to replace the x's, so replacing these with your actual answers here. So your matrix will look like this. So it's going to be a 2 by 2. But it's going to be, instead of the x's, we're going to replace that with 28 and 8. And then our y's stay the same, so 4, negative 2. Okay, so this is going to be the determinant you need to use to find the x matrix. Okay, to find the y, you're going to just do the opposite. You're going to place 28 and 8 with the y's. Okay, so first we're going to find the determinant of this. So 28 times negative 2 is negative 56, minus 8 times 3 is 32. Negative 56 minus 32 is negative 88. Okay, so just remember that. Okay, then I need to scroll down. And then the next one, we are going to replace, we need to find your y matrix. So we're replacing your y coefficients with the 28 and the 2. So we get 5 and 3 for your x's, because we're leaving those alone, and then we replace the y with 28 and 8. Okay, we find the determinant, so 5 times 8 is 40, 3 times 28 is something, 84. 40 minus 84 is negative 44. Okay, so we have our x, which was negative 88. Okay, that's not your x value, but that's our x matrix determinant. Okay, we have our y, which was this. And then to get the last one, we just do the x's and y's. We don't replace anything. So we do 5, 3 for your x's, and 4, negative 2 for the y's. So this one we don't use the right side of the equation. We define the determinant. Well, that's going to be negative 10 minus 12, which is negative 22. Okay, so these are the three numbers that we need to focus on. Okay, now step 3 is to find x. We take our first determinant, our x determinant, which was negative 88, and we divide by our last determinant. This is our denominator determinant, the last one here, which was negative 22. And that gives us 4. So our x value is 4. To get y, no, that's x. To get y, we divide the y by the negative 22. So y was negative 44. divided by negative 22 gives us positive 2. So our point is 4, 2. Okay, so that'd be the solution of that equation. All right, so it might be easier just to use substitution elimination here. However, we can actually apply this to 3 by 3 matrices as well, and 3 variable equations. So that's when Cramer's rule comes in handy. So for example, if I have a system of 3 equations, so I have x, y, and z here, that means I need 3 equations to solve that. It's going to take a lot more substitution / elimination to simplify these things. So in this case, it might be easier to use Cramer's rule and to find the determinants and stuff. So it's the same idea here. We're just working with 3 by 3 matrices. So let's scroll down here. So the first thing you're going to do is you need to find your x values. So the numerator for the x. So basically we're replacing these x's with our answers again. So now you find the determinant for 6, so replacing the x's, negative 15 and negative 10. And then y's and z's stay the same. So that would just be 1, 1, negative 3, 1, negative 4, and 1. Okay, and I'm going to pause this and do this really fast. You guys can try it as well. That way we don't take up more time. Okay, pause this in 3, 2, 1. Find the determinant of this. Pause. Okay, so I got 44 by the diagonal method. So I multiplied diagonals and then I added the bottom ones. So these were positive, these ones were negative, and total came out to be 44. Okay, so when we remember that one, that is for the x's. Okay, then we have to do the y's and the z's also. So, one second. Okay, so in the next one we're going to replace the y's with the last column, the 6, negative 15, and 10. So we do here. We do here, and the x's are going to be 1, 2, and 5 still. The y's we're replacing with 6, negative 15, and 10, negative 10. And then the z's are 1, negative 4, and 1. They'll stay the same. Okay, and again we copied down the first 2 columns, 1, 2, 5, 6, negative 15, negative 10. And then we can do the diagonal method. So I'm going to let you do that, and I'll do it, and then we'll come back. Okay, pause this in 3, 2, 1, pause. Okay, so doing the diagonal method, multiplying diagonally down and up, I got negative 15, negative 120, and negative 20. Those are all being added together. And then going up, I'm subtracting negative 75, so plus 75, subtract 40, and subtract 12. And that I ended up with negative 132. So that's going to be our y. We're going to use that for y, so remember that one. So we have 44 for x, negative 132 for y. And now we're going to go to the other page. Alright, and the next one we have to replace the z's. So we've done x's, y's, and now we're replacing z's. So the x is going to be 1, 2, and 5, so it stays the same. Y is going to be 1, 1, and negative 3. Then the z's we're replacing with 6, negative 15, and negative 10. Okay, I'm going to copy down the first 2 columns again. 1, 2, 5, 1, 1, negative 3. And then we go from there again. So go ahead, pause this, try it, and I will do the same thing. Pause this in 3, 2, 1, pause. Okay, so multiplying diagonally. These ones, remember, they all stay the same. These ones are all changing signs because they're going to become negatives. Or if it's negative, it's going to become positive. But I got negative 176. So this is for the z, the z's. Okay, and then the last one we need to do is just keep them all the same so we can find our denominator matrix. So down here, where you leave all of them the same, so x's, y's, and z's. So that's going to look like 1, 2, 5 for x, 1, 1, negative 3 for y, and then 1, negative 4, 1 for z. And again, copy down the first 2 columns. So 1, 2, 5, 1, 1, negative 3. Okay, go ahead, find the determinant of this one, and then we will come back. Pause this in 3, 2, 1, pause.
Noah Hyman.
Okay, so for our last matrix, I got negative 44. So this is the one that's going to go on the bottom of all of our fractions. So for our x matrix, so for our x coordinate, we get x is 44, because that's what we got for x, divided by negative 44. So that's going to simplify to be negative 1. Y was negative 132, divided by negative 44. So that's going to be a positive 3. And then z was negative 176 divided by negative 44, which will be a positive 4. So our ordered pair here, or our ordered triple, I guess in this case, would be negative 1, 3, and 4. Okay, and that is how we can use Cramer's rule to solve equations in 2 or 3 variables. And the last thing we were doing, and I know we're way behind schedule, but this one is quick compared to the last 2 things. But the last thing is finding the multiplicative inverse of a matrix. So why do we need them? If you're working with equations that have matrices present, you may need to cancel out a matrix in order to find your solution. So to cancel out a matrix, you need to multiply it by its inverse matrix. Okay, so let's just say, why do we need this? To solve matrix equations. Okay, so if we have the matrix A, which is just A1, A2, B1, B2. Okay, and the determinant does not equal 0. Okay, so the determinant of a 2 by 2, you just multiply the diagonals and subtract them. And the inverse is written like this, a to the negative first power is what it looks like, but that's really just the inverse matrix, is 1 over, whoops, I don't want that yet, is 1 over the determinant times by, now you're going to rewrite this matrix A, but you're going to switch a couple things. So you're going to switch the A1 and B2, so this is not going to be B2, this is going to be A1, and then the other ones stay in the same spot, but they become negative. So negative B1, negative A2. Okay, so that's what the formula is for a 2 by 2 inverse matrix. So for example, if we do A as 5, 3, and negative 8, 6, the inverse, A inverse, I have to do 1 over the determinant, so 1 over, I'm going to multiply this way, 6 times 5 is 30, minus negative 24, so plus 24, and then times that by, okay, I'm going to switch the 6 and the 5, so that becomes 6 and 5, and then the other ones become negative, negative 3, and that becomes a positive 8 now, because it was negative already. Okay, so then we just get 1 over 54, if we simplify that, times all of those things, 6, negative 3, 8, 5, and then we would have to distribute the 1 over 54 into the matrix, but I'm going to skip that. It would just be 6 over 54, negative 3 over 54, 8 over 54, and 5 over 54. Then you would solve, you would simplify the fractions. Okay. Okay, so I have this system of equations, and I'm going to show you how we can use inverse matrices to solve this. So we have 2x minus 3y equals 17, and 3x plus y equals 9. So we're going to rewrite this system as a matrix equation. So the first thing you do is you write your coefficient matrix, which is just the coefficients of your x's and y's. So we do 2, 3, negative 3, and 1, times your variable matrix, which is just x, y, just tells you what your 2 variables are, and then that equals your solutions matrix, which would be the 17 and 9. Okay, so the first step is to find the inverse of your coefficient matrix, because really if we want to get x, y by itself, you want to solve this equation, we need to get rid of this guy. So we need to find the inverse of that so we can cancel it out. So we're going to do the determinant. So let's just call this A inverse. So the determinant is going to be 1 over 2 times 1 is 2 minus negative 9, and then we switch the 1 and the 2 and make everything else negative. So negative 3, that turns into positive 3 up there. Okay, so that just becomes 1 over 11 basically. And if I distribute that in, sorry, I'm kind of skipping some steps because I'm trying to hurry. We get 1 over 11, 3 over 11, negative 3 over 11, and 2 over 11. Okay, so that would be our inverse matrix. Okay, next you're going to take your inverse matrix and you're going to multiply it by each side of the equation. So basically you're going to take our 1/11, 3/11, negative 3/11, and 2/11 times the left side, which would be 2, 3, negative 3, 1, and then you still have this xy over here. Then you also have to multiply it to the right side. So we do your inverse matrix, 1/11, negative 3/11, 3/11, that's a 3, and then 2/11, times by the solution matrix here, 17, 9. Run out of space here. Hopefully you guys can see that. Okay, and then basically what happens, because these are inverses of each other, they just cancel out. So then we're just left with xy equals, and then we just multiply these two matrices together. So this is a 2 by 2. This is a 2 by 1. So we can multiply them, and then our result is a 2 by 1. So it should look like this. I'm going to get rid of that right now. Okay, so I multiply row times column. So that's going to be 1/11 times 17, which is 17/11 plus 3/11 times 9, which is 27/11. And then I do second row times first column. So negative 3/11 times 17, which gives you negative 51/11. Plus 2/11 times 9, which is 18/11. And then if you simplify all that, that becomes 17 plus 27 is 44. 44 divided by 11 is 4. Negative 51 plus 18 is negative 33. Divided by 11 is negative 3. No. Negative 3, right? Yeah. Okay, so this tells us that x should be 4 and y should be negative 3. So your solution would be 4, negative 3. And that's how you can use inverse matrices to solve systems of equations. I know this video is super long, so I am going to end it really fast. So please take the quiz. See y'all tomorrow. Bye.